So welcome back. We're going to start a new lesson this evening. This is probably going to be lesson 4A. So we'll move into a different area. We're going to get into some more with exponents and some other operations. But first, I want to just get into prime numbers. Prime numbers are special numbers in math, and a lot of times what we're going to use them for is to factor or break down a number. So we're going to factor or break down a number. So when we talk about factors, when I look at the number, the expression 5 times 4 is equal to 20, the numbers connected by multiplication are called factors. And then the answer to the multiplication problem is called the product. So the factors are the pieces connected by multiplication. Now, prime numbers are very special because those numbers actually don't break down themselves. They only have two factors, 1 and itself. So a prime number only has two numbers that multiply to give you that number, 1 and itself. So if I look at 2, the only way to get a 2 is 1 times 2, so it's called prime. Notice 4 is not there because there's another way to get a 4. 2 times 2 is also 4. So 4 actually has 3 different factors. So 4 is not prime. But notice how 3 is prime because 1 times 3 is the only way to get a 3. 5 is prime. But notice how 6 is not there. So notice that 2 times 3 is also 6. So that's 4 different factors for 6. So 6 is not prime. But these are your main prime numbers that we're going to deal with. Again, these aren't the only prime numbers out there. These are the only prime numbers that we'll probably use, but most of the time. There may be exceptions, but for the most part, if you can memorize 2, 3, 5, 7, and 11, that'll take you a long way down the road with factoring. So let's write the prime factorization of the following. So let's break down this 12. What I'll do is I'll use a T-chart to kind of organize. And what I'll do is I'll put the 12 up here at the top. What I want to do is just start with the number 2 and ask myself, will 2 break the 12 down? In other words, can I divide 2 into 12? And since 2 does go into 12 6 times, we use the 2 because it breaks it down. So now I'm looking at the 6, and I'm sticking with that 2 until the 2 doesn't work. Can I use a 2 to break down to 6? So does 2 go into 6? Well, 2 goes to 6 3 times. So now I'm looking at this 3. But I recognize 3 as a prime number, so the only thing that goes into 3 is 3 goes into 3 one time. When I get this little 1 here, circle that. That tells that you're done. Our prime factorization are these numbers on the left. These are the numbers that multiply to give you a 12. So I can write 12 as 2 times 2 times 3. And that's called the prime factorization of 12 because 1, prime, these are prime numbers. Factorization kind of implies the pieces that you multiply together to get a 12. And we know that 2 times 2 is 4, and 4 times 3 is 12. So this is just another way to write 12 in the form of a prime factorization. Let's look at the number 28. Again, I'm going to use a T-chart, and I'm going to try to break this 28 down. And again, I'll just start with my 2. I'll work my way through. Does 2 go into 28? Well, since 28 is even, I know 2 goes into 28 because half of 28 is 14. So 2 goes into 28 14 times. Now my attention turns to that 14. I want to see if I can break it down. Let's stick with the 2 until it doesn't work. Does 2 go into 14? Well, 2 does go into 14 7 times. Now we turn our attention to a 7, and notice that 7 is a prime number, so the only thing that's going to go into 7 is 7 itself. So 7 goes into 7 one time. So this over here represents my prime factorization of 28. So I can write that as 2 times 2 times 7, and that would be what we call the prime factorization of 28. Let's turn our attention to this 84. So again, I make my little T-chart, put the 84 above it, and I see if I can break that 84 down to 2. Well, since 84 is even, I know 2 will go in 84, I believe it's 42 times. Yeah. So now I turn my attention to that 42. Will 2 go into 42? Well, 2 will go into 42 21 times. Now, since 21 is odd, I know 2 does not work. Let's look at that 3. Does 3 go into 21? So if I think about that, if I need to use a calculator, 21 divided by 3, and yes, it does give me 7. So 3 times 7 is 21, so that tells me that 3 does go into 21 evenly. So 3 went to 21 7 times, and again, notice that I get that 7 there. 7's a prime number, 7 goes into 7 one time. And therefore, 2 times 3 times 2 times 2 times 3 times 7 would be my prime factorization for 84. So 2 times 2 times 3 times 7 is my prime factorization of 84. Let's look at this 132. So again, I'll write the 132 over here. And again, I'll start with that 2. Well, 2 go into 132. Well, yeah. 2 will go into 132. I believe that's 66 times. 132 divided by 2, 66 times. Yeah, that makes sense. I can stick with that 2 because 66 is even. 2 goes in 66 33 times. Now I turn my attention to the 3. Does 3 go into 33? Yeah. 3 goes into 33 11 times. And then if you notice, well, 11 is a prime number, so the only thing that's going to go into 11 is itself. So 11 goes into 11 one time. Again, once you get to that 1, you've completed your prime factorization. So our prime factorization is going to be this 2 times 2 times 3 times 11. So right there is 2 times 2 times 3 times 11. And that would be our prime factorization of 11. So what's interesting, a lot of times we're used to putting numbers together. In algebra, it's also important to be able to break numbers back apart in the form of, especially with multiplication and division. So interacting with multiplication and division is a very powerful tool. It's going to help us simplify problems that we may not be able to without a calculator. So stay tuned.